So let's focus on how to integrate tan to the power of n of x multiplied by sec to the power k of x dx, right? Where k is even. Where k is even, that means where the power of the sec is even. So example 1, let's evaluate tan to the power 6 of x multiplied by sec to the power 4 of x dx. So looking at this question, I know that it's more or less similar to one of the strategies that we did over there. These are some of the strategies that we were doing. So yeah, that's when k is even and k is even greater than 2, which is now here. You can see that k is 4. You can see that k is actually at 4, and we were told that if we see k is even and then k is greater than 2, we should express the sec and its power in terms of this, right? So let's quickly solve it. So having integral of tan to the power 6 of x sec to the power 4 of x dx. Now, as I said, the 4 is even, which is the power of sec, and therefore we can rewrite this sec to the power 4x as equal to sec square of x and then sec square of x. This came to sec square of x and sec square of x because remember that our first strategy is like k minus 2 and then 2, then sec square of x. So this is sec k power k minus sec of k minus 2, and so yeah, that's how it is. So now we have been able to express this sec power 4 in this form, sec square of x multiplied by sec square of x. From there, we can use the identity, as I told you, 1 plus tan square of x plus 1, or okay, I've already written the 1. 1 plus tan square of x is equal to sec square of x, and therefore we can rewrite the first sec of x in terms of tan x. So in doing that, we are going to get something like integral of tan to the power 6 of x, and then this one must be replaced by tan square of x plus 1, and don't forget our other sec square of x again. Now we can say that let u equal to the tan x, which was not tempered, and therefore my du dx is equal to sec square of x. So making dx the subject, you will get dx equal to du over sec square of x. Now since we said let u equal to tan x, the whole function changes to be integral of u to the power 6 into bracket u squared plus 1, and then multiply by sec square of x, and then dx. Don't forget that. So now we have our dx here to be du over sec square of x. So in substitution, we are going to get integral of u power 6 u squared plus 1, and then sec square of x, and then the dx is du over sec square of x. Now we have some terms in common inside and we can cancel them out. So from there we will get everything in u variables, which becomes far easy to manipulate and solve than the one which was given initially. So in simplification, we are going to get u to the power, u to the power 8 plus u to the power 6. So now that we have this, that's the expansion that we have done here, and then we can go ahead to do our integration. So doing the integration, we are going to get 1 over 9 u power 9 plus 1 over 7 u power 7 plus c. And don't forget that we said that let our u equal to tan of x. And if u equal to tan of x, we can see that then our final answer is going to be 1 over 9 tan of 9 of x, right, plus 1 over 7 tan of 7 of x plus c. So this is actually going to be our final answer for it. So basically, if you don't understand it, please pause the video, go back and re-watch it again. But before I end this part of the tutorial, or let's see whether I'll solve one more example and then give you additional one to solve.